Hi, everyone. My name is Sarah Grace Mitchell, and I'm a sales manager with CORYS. I'm excited to speak to you today to give you a quick overview of our software. Following my presentation, you will hear from one of our engineers, Mr. Suhas Kulkarni, who's going to give you an in-depth software demo of one of our models. So let's begin by understanding what an operator training simulator is. If you compare it to a plant has process units like an FCC or a distillation unit. There are field operators who are in the field opening and closing valves, starting and stopping pumps, etc. You have a DCS control system, you have an SIS or an ESD control system, and you have your DCS operator stations in your control room. Now, if you look in the operator training simulator world, the process units are modeled in CORYS's Indus Plus dynamic simulation platform, which runs on a Windows desktop PC or a Windows server. We offer an optional field operator station where a field operator trainee can perform field functions, or this can be incorporated into the instructor station. The DCS is simulated by a DCS simulator, and the SIS is simulated by an SIS simulator. Then you would have your DCS operator trainee stations. The component that doesn't have an equivalent in the plant is the instructor station, and this is where the instructor sits, and he or she will run the simulation, introduce malfunctions, activate training scenarios, etc., which we will see in a few minutes during our demo. Though the OTS is commonly associated with trainers and operators, OTS can actually be used by everyone within your organization. Engineers use it to streamline your process and test new control schemes. Operators, both new and experienced, use it to train on everyday procedures and more uncommon things like emergency conditions. Managers utilize it to lower operating expenses, and HR enjoys its easy integration with your LMS and its capture of best practices. CORYS owns a proprietary simulation platform called Indiss Plus. It's high fidelity and extremely accurate in its matching of the actual plant performance, and it can be used for DCS link or emulation. It allows for linking to third-party software via the CAPE Open Interface Standard, which allows for plug-and-play interoperability with third-party process modeling components, such as compressor or reactor models. It includes a trending and data historian, and it allows for DCS graphics on the instructor station and field operator station HMIs. And it has advanced functionality, which we're going to get into in just a few minutes when we run the software demo. These are all the standard refinery models that we can provide. We provide both component or small system models, which you see on the left, as well as models of entire refinery units on the right. These models are available in the cloud on a subscription basis with no software license fees. Please contact me if you would like more information on any of these. With a subscription, we include setting up the selected models in the cloud and providing login credentials to the instructors and trainees. We provide training sessions for the users and the instructors with additional support as needed. In terms of training materials, the models come with a user manual, which gets granular in the descriptions of the process unit and the control scheme, as well as the simulator functions and startup procedures. Then we also provide a customized companion training manual, which is a classroom curriculum and description of the custom simulator training scenarios developed in coordination with your site's SMEs. Finally, we can consult on your overall training program and develop a training master plan to incorporate multiple simulation models into the curriculum, which is especially useful for the models if you're going to spread them across multiple sites. Now I'm going to turn this presentation over to my colleague, Suhas Kulkarni, who is going to give you a demonstration of our simulator capabilities.
Hello everybody, I'm Suhas Kulkarni. I'm a lead engineer at CORYS. Today I'll be demonstrating the Indus Plus operator training simulator software. I'll be showing you the instructor station and the emulated DCS operator station. So I'll be going between the two views. So one screen will be the instructor station and the other one will be emulated DCS operator station. So let's get started. I'm going to first start the instructor station view. So there will be an icon like this on the instructor station in the OTS. So I double click on it. So the instructor station is where the trainer or the instructor sits and basically controls the training session. He runs the simulation, he can freeze the simulation, He can introduce malfunctions, scenarios, change battery limit pressures, temperatures. So you get a splash screen. So I'll click on the title. So this demo is for a single distillation column. It's a debutanizer application. So it's a column with all its peripherals. You have a water-cooled condenser, a reflux drum, reflux pumps with one running and one spare. You have a steam heated reboiler. You have a water-cooled bottoms cooler. You have a pressure controller on the reflux drum, so it's a vapor product here. You have the feed system with the feed control valve. So if you look at the top here, this is an instructor toolbar here. This is where he can do a lot of instructor functions. So let's start with the starting point for the simulation. So if I'll click on this drop-down menu, I see a lot of these initial conditions. So initial condition is a starting point for the simulation. So I can start with normal operation, which is basically where the plant runs most of the time producing the product at capacity. Or you can start at a cold start initial condition. And this is basically all the equipment is shut down, pumps are stopped, valves are closed, all the equipment is de-inventory, depressurized and at ambient temperature. So this would be the starting point for a startup training exercise for the trainee operator. But normally we provide about 2 to 3 initial conditions with the simulator, a normal operation, a cold start, and maybe a hot or a warm start. But the instructor can create many initial conditions during his training session. So it's very easy to save an initial condition. So let me load my normal operation initial condition. To save an initial condition, you just go to this and type the name of the initial condition you want to save, and click on save. And now it will be available in the drop-down menu of the initial conditions. So it's saved on the hard disk of this computer. To run the simulation, you would click on the run button here. So you can see that the simulation time is increasing. So that means the simulation is running. So the simulation is built to run in real time. That means any process changes that would take about an hour or so in the plant would take the same time in the simulator. So if there was a feed upset and it takes about an hour for the plant to stabilize, then it would just take the same time in the simulator. You do have a speed up function, so you can speed up the simulation. So I go to fast mode and now I run it. So now I'm running 10 times faster. This is normally used during startup, so like pressurizing and inventorying the process. That's when this speed up function is used. Otherwise, during normal training, you would run at normal speed. So the other functions that are available to the instructor are the field view. So there's an FOD button here. When he clicks on the FOD button, he can see all the field functions available to him. So you can see the cooling water valve appears. It's a manual valve in the field, which is not shown on the DCS graphic. So when he clicks on it, it appears, plus if you click on a control valve, he can now operate the upstream and downstream block valves. You can operate the bypass valve. You can fully open it. So this can be used, for example, for control valve failure kind of exercise. He can stop the pump from the field. So let me go back to my normal operation here, run it. So the other feature available for the instructor is malfunctions. So I'll click on my malfunction button here. And now I can see these thunderbolt signs on all the equipment where there's a malfunction available. So for example, on a control valve, the instructor can fail open it, fail close it, stick it, put leakage or plugging. So So if you fail close the valve, then I have to click apply to ensure. So the valve fails close and the flow goes to 0. So this is the situation where they can operate the bypass valve to operate the process. So basically isolate the control valve and then use the bypass valve to operate the process as close as possible to normal operation. Other failures are pumps, like all motor driven equipments, like a pump can be fail stopped. Also instruments have malfunctions, so any transmitter, flow transmitter, temperature transmitter can be fail low, fail high. So fail at its low range, high range, you can freeze it, bias it, add noise, drift. So I can fail this transmitter low, that means the flow is going to go to 0. You also have standard malfunctions for heat exchangers, so you can foul the heat exchangers. So let's go back to, I'm going to load the normal operation. The other function available to the instructor is what we call instructor variables, which allows him to change feed conditions. So you can change the feed temperature, feed pressure. So wherever you see this hand with a pen, there's an instructor variable available. So this one allows the instructor to change the feed pressure, temperature, the feed composition. He can also change the cooling water supply, pressure or temperature to simulate like cooling water failure, complete loss of cooling water or partial loss of cooling water, or the cooling water temperature going up or down. So these can be used to simulate different scenarios, different kinds of upset that might happen in the plant. You can mimic those in the simulator utilizing these malfunctions and instructor variables. In addition to this, you also have what we call as custom malfunctions, which allows you to basically introduce process-specific malfunctions like tower flooding or foaming or hydrates formation. So these are programmed in the simulator based on the customer input, and they are customized for every process. So I'm going to now switch to the DCS operator view, the emulated DCS operator. This is where the trainee operator sits and performs his function. So I'm going to start the emulated DCS operator station. So you will see that the graphic is basically the same as what we've been seeing on the instructor station. So again, you get the splash screen. However, there is no top toolbar, so he cannot run the simulation or pause it. That's an instructor function. So he basically operates from this screen as if he were in the control room and operating the real plant. So I'll go to the instructor, make sure that I'm running the simulation, and now the operator basically can open the like a PID faceplate for this flow controller, change the set point, maybe decrease the flow to 35,000. So you can see the valve is closing. You can monitor it on the trend. You can put the controller in manual and reduce the valve output to say 45%. So you can see green is the controller output, red is the set point, and blue is the PV. So it went down. You can put it back in auto and give the normal set point of 35,000 and let the controller take the process back. You can monitor the process. He has a trend overview, so there will be a trend available just like a DCS. So this is what we call a generic DCS that kind of CORYS has developed for its generic kind of simulators. But when we emulate a specific DCS like Delta V or Centum VP or Honeywell Experion, then all these faceplates and the graphics will look like those DCS graphics. So we would make these graphics look like your plant graphics. But for this demo purposes, we are using what we call a generic DCS look. So let's do a simple exercise where the instructor introduces a malfunction. So he's going to trip a pump, this running reflux pump. So he's going to turn on his malfunction view and basically fail the running pump. So as soon as he does that, we'll switch to the operator view. The operator will see that the flow, reflux flow went to 0. He sees that the pump has stopped. He can go and see the alarms. So the alarm, the low flow alarm is active. So you can acknowledge the alarm. Navigate back to the process graphic. So then he needs to diagnose the problem. So in this particular case, you can see that the pump has stopped, the running pump, and he has to start the standby pump. So since this is a field operator pump, he has to tell the field operator, in this case the instructor, to start the pump. So I'm going to switch back to my instructor view, and on the instructor I'm going to go to my field view and start the pump. If you had a separate field operator station, then it would be this function of starting the pump would be done on the field operator station. So now the pump is started. So I'm switching back to the DCS operator view, and he sees that the pump started, the flows are coming back. So you can see the PID controller is trying to take it back to its set point. So then he can monitor the process and ensure that everything is going back to normal. He can take whatever corrective action he can on his DCS screen. So now the instructor decides that, okay, this was a good exercise. Let's go back to the normal operation and run the simulation. So this time we're going to do the same malfunction, but we're going to use a feature that is called training exercises. So let's look at, so you can develop these training exercises, which are basically malfunctions or actions that can be programmed and then can be run as an exercise. They can be run by the instructor or by the trainee, and they would not know what's programmed in that exercise. So let's look at this exercise one that was prepared for this demo. I'm going to edit it. So these exercises are developed like a flow chart. They can be either programmed by like dragging and dropping these different functions on here, or you can also record them. So if I'll walk you through this particular one. So the first step in this exercise is to load a normal operation initial condition. You can change that. You'll have the same drop down menu. So you start with the normal operation initial condition, then you start the simulation, you run it for 10 seconds, and you can change that if you want. Then you introduce a pump failure, the same pump that we failed manually before, the running reflux pump. Then you start a program called TPM, an Indiss Plus program. It's trainee performance monitoring. Basically, this allows the program to monitor certain variables, and those variables are programmed by the instructor or by us for the customer. And then it monitors those variables for 5 minutes here, and that's basically the time you're going to give the operator to recover from this upset of the pump failing. And then the TPM program will stop, and then the simulation will stop. So whenever this exercise is run, it's going to run for basically 5 minutes and 10 seconds for anybody who runs this exercise. You can see it's 5 minutes 10 seconds before the malfunction, and then 5 minutes after that. So if you want to look at what's in the TPM, I'm going to go to the TPM tab here. I'm monitoring the reflux flow, and I'm giving it a limit of 33,000 to 37,000. So the normal process value is about 35,000. So I'm saying that the reflux flow should be between 33,000 and 37,000 at all times. The level that I'm also monitoring the reflux drum level, and it's at 50% normally, and I'm saying that it should be between 48 and 52 at all times. I'm also giving a weight, so whenever these variables are outside their limit, what's the weight what's the penalty, how heavily should the operator be penalized. So for example, reflux flow is more important, so it carries a weight of 2. The level not so much, so it has a weight of 1. But you can basically have a weight of anywhere between 1 to 10. 10 being the highest penalty and 1 being the lowest. So you can program as many variables as you want for any exercise. So now I'm going to run this exercise. So I just click on run. So it's going to ask what is the instructor name for this, who's the instructor for this exercise, who's the trainee. So say it's going to be John, and do you want to compute the evaluation score. So you can either check it or uncheck it. So if you check it, then it's going to give you a score, and you'll see it in the end when it dumps a report of the exercise. So I'm going to start the exercise. So now the system loads the initial condition normal operation, then it will run for 10 seconds. So let's look at this time, 10 seconds. And then it will activate the malfunction for this pump. So the pump failed stop. Again, the flow is going to go to 0. And so now on the DCS screen, the operator is going to notice that the pump has stopped, the flow has gone to 0. So he has to basically start the standby pump. So he's going to tell the instructor to start the standby pump. So on the instructor station, I'm going to go to my FOD view and start the pump. So now you can see that the pump has started and the flow should be starting to come back. So now I'm going to go back to my instructor view. It's a 5-minute exercise, so I'm going to speed up to get to the 5 minutes because there's nothing more to do in terms of corrective action. So you'll see that at the end of 5 minutes, the system will create a report of the exercise and also give a score for the operator performance on this exercise. So we are getting close. So then the system report generates a report. You can see that. So it's the AT, the exercise is exercise 1. That's the name of the exercise. Instructor is myself, trainee is John. Duration was 5 minutes and the score was 86%. So that's pretty good. So it gives you a statistical analysis of all the variables that were being monitored by the TPM. So for example, the reflux flow crossed the low limit alarm once, which is expected because the pump stopped, and it crossed the high limit because the flow controller, the reflux flow controller wound up to 100%, and so you had a spike. How long was the excursion below the low alarm? How long was the excursion above the high alarm? How many low and what was the total excursion time if you had multiple excursions? And the score for that particular performance of that particular variable. So similarly, it gives the same statistical analysis for the level. It also gives you a trend, and the trend you can zoom in or zoom out. You can also see the values. So this is a PDF file, but you can go and scroll and look at the values. How high was the peak? You can see the peak on the reflux was about 43,000. Similarly, you get the trend for the level. So it goes up to 70% and then it's coming back down. So you have all the data that you need. It also gives you how the score has been calculated, the formula being used. So this can basically be dumped to your LMS system, your learning management system, or saved in a folder, or you can print it and save it in a binder. But it becomes basically part of the trainees training program. So now I'll briefly show you the actual engine that basically runs this thing. So this is the Indiss Plus model. This is the engine that runs under the hood. So this is the model that's running in the background. So this is how we build the model. So if you look at this, there's an overview sheet, and then we create sheets for every PNID. And if I go to the process, I can navigate here to the column. So this is what the column looks like in the model builder. So here's the feed system. So here's the feed battery limit with the pressure, temperature, and the composition. So you can see got some butane, hexene, hexane. This is the flow control valve. So the valve, you have to provide the valve CV, the nominal CV at 100%, and the characteristics. So it can be a linear valve or equal percentage valve. So for the column, you have to, it's a tray by tray simulation. So this particular column has 22 trays plus the bottom drum. They are all sieve trays. We provide all the dimensions for the trays. The heat exchanger, the reboiler, it's a shell and tube, so you have to provide the heat transfer area, the heat transfer coefficients. For pumps, we have to provide the pump curve. So we have a library of all these unit operations. So if you go to the library, you can drag and drop. So if I want to create a pump, I will basically create a pump, drag and drop it, and provide the pump curve. So I can provide the pump curve. Similarly, if there was a compressor, I would provide the compressor curve. If I have a valve, I can drag and drop the valve, provide the CV and the characteristics. So this is how the model gets built for the process. So this concludes the demo of Indiss Plus. If you have any questions, let us know. Thank you.
Thank you, Suhas. If you have any questions, please do not hesitate to contact me. My contact information is on the screen. We're happy to provide virtual lunch and learn presentations to your organization, which included a demo of our software. We'll be putting on a webinar in December highlighting our 3D technologies. So please contact me if you'd like more information on that. I really appreciate your time and enjoy RefComm.